Alright, so today we're going to look at how to name the first three classes of organic molecules. So the way we name organic molecules is we break them up into quite a few different classes, and each class of molecules has their own set of rules. So the first group we want to look at are referred to as saturated hydrocarbons. So saturated hydrocarbons, as you can guess by the name hydrocarbon, contain only hydrogens and carbons, and they contain only single bonds. Okay, so that is important. So if I didn't mention it before, the notes are kind of backwards. The first page in your printed note should be the last page. It's something you should do when you completely finish. Go back and kind of summarize your thoughts. So don't start there. Start on page number 2. So the first group of, or really the only group of unsaturated, let me back up, of saturated hydrocarbons that we'll deal with, we call alkanes. Okay, so you could define alkanes as being carbon and hydrogen containing molecules with only single bonds. Okay. So in the word alkane, go ahead and label, or underline the letters A-N-E, okay? So let's go ahead and jump in and start naming a few here. So I'm going to draw a structure, and we're going to name it. So the first step is to count the number of carbons. There are 1, 2, 3, 4. Okay, so I have 4 carbons. So I have to think back to what is my prefix for 4 carbons. Those you should have memorized. Okay, so butyl. Okay. So I look at this structure. It contains only carbon and hydrogen. There's nothing else going on. It's only there are only single bonds, so it's an alkane. So I change the YL ending to the ANE ending. So it is butane. That's the name of the structure. Okay. Then I could also go back and add or count the molecular formula there, but I'll stop at naming it. So let's draw another one and name it. Okay, so let's count the number of carbons. 1, 2, 3, 4, 5. So my prefix is pentyl. There's nothing strange going on. It's only carbon and hydrogen. There are only single bonds, so it's an alkane. So we use the ending ANE. So we change pentyl to pentane. Okay, so fairly straightforward there. So I'll give you one to try. You can go ahead. I'll go back up here. Draw octane. Let's go in the opposite direction. So go ahead and pause the video and try and draw octane. Okay, so let's go ahead and draw it together. So I have 2 carbons, 3 carbons, 4 carbons, 5 carbons, 6 carbons, 7. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So every time you get done, be sure you go back and count how many carbons you have. 1, 2, 3, 4, 5, 6, 7, 8. You could have also drawn it like this. And those are the exact same thing. If you flip it in the opposite direction, that's perfectly okay. Yeah, I just happen to start going up. That's typically standard convention. So what about propane? Okay, so the prop tells us 4 carbons. The ANE tells us that it's only hydrogens and carbons, and that there are no double or triple bonds. It's all single bonds. So 3 carbons. Nothing strange going on. It ends in ANE, so we're good here. You might ask about methane. Okay, so methane, the meth tells me 1 carbon, the ANE tells me only carbon and hydrogens. Methane, we don't really draw just a dot for. We would just show CH4 for methane. It's such a simple molecule. Okay? So that's by far the easiest class of organic compounds that we could deal with. And we can make this a lot more complex. We haven't, by any stretch of the imagination, exhaustively named these. We could make these chains more complex, and that would really change things up. But for the sake of this class, we're just going to learn the simplest cases for each of these categories. So now we're going to move on to unsaturated hydrocarbons. So unsaturated hydrocarbons contain a double or triple bond somewhere in the molecule. So when you hear about saturated and unsaturated fats, then you have an idea what that is. So if it's unsaturated, it has a double or triple bond, which means it has less hydrogens than it could have. Okay. So if we think about what that means, we can have this molecule and this molecule. So they both have 3 carbons. We know that. This one is saturated. This one is unsaturated. So this one would be C3H8. This one would be C3. Then we have 3 4, 5, 6, H6. So if they're unsaturated, they're considered to be unsaturated with hydrogen. They have fewer hydrogens than they could have. But we typically recognize a compound as being saturated versus unsaturated by its presence or absence of double and triple bonds. Okay? So the first category of unsaturated hydrocarbons that we'll look at we'll refer to as alkenes. Okay? Alkenes contain a double bond. So, and they contain only hydrogen and carbon. Okay, so if it has something besides carbon or hydrogen, it's no longer an alkene. Okay, so let's look at one. So let's look at this. Okay, so first we have to recognize it's only hydrogen and carbon, so we're good. And it has a double bond, so it's an alkene. So an alkene, let's underline ENE here. Okay. So we still go back to our prefixes. There are 1, 2, 3, 4 carbons. So the 4 carbon prefix is butyl. Okay. Then butyl becomes butene. Okay, so butene versus butane tells me there is a double bond in that molecule. There's a little bit of an issue with this name though. What about this? Okay, that's a different compound, but if I use the rules I just did to name this, I would come up with the same name. So I can't have two different compounds with the same name. So when we have an alkene, you have to tell me where the double bond is. Okay? So what do I mean by that? I mean you have to number the carbons and tell me what number carbon it's on. So we'll number the carbons. 1, 2, 3, 4. Okay. So you tell me the number that the double bond starts on. So I can name this compound as 2-butane. Okay. So the but tells me 4 carbons. The ENE tells me there's a double bond. The 2 tells me where the double bond is. And you might ask, why did you start numbering on the right? Well, in this case, if you numbered from the left, 1, 2, 3, 4, you would still say the double bond starts at the 2. You want to give it the lowest number possible and get the same answer. So let's look at this one down here and we'll see why we number. So one option is to number it, or why we number in a certain direction rather. One option is to number 1, 2, 3, 4. The other option is to go 1, 2, 3, 4. So we always want to give the double bond or the triple bond or whatever extra part of the molecule besides just a single bond is going on the lowest number possible. So I would number 1, 2, 3, 4. Okay. So now I have 1 butane. Okay. So notice the alkene, the double bond, is touching the second carbon, but it starts on the first carbon. You want to give it the lowest number possible. Okay. So let's look at another example here. So I like to kind of think about these in pieces. The first piece I have to worry about is, well, what's my prefix? Because I know I'm going to use that. So let's count the carbons first. 1, 2, 3, 4, 5, 6. So I know I have hexyl. Okay. Is there anything besides a carbon or a hydrogen in this molecule? No. So we're good there. Is there a double bond here? Yes. So I know it's an alkene. So I know it ends in ENE. So I know it's hexane. So hexane just tells me it's a 6-carbon molecule with a double bond somewhere in it. Now I have to tell you where it is, where the double bond is. So I want to number it so that I give the double bond the lowest numbers possible. Okay, so I number in this direction. If you number in the opposite direction, you would see the double bond would have a higher number there. So the double bond starts at 2. So I would call this 2-hexane. Okay, let's try one more. So let's go ahead and count the number of carbons first. 1, 2, 3, 4, 5, 6, 7. Let's go ahead and put one more on there. Let's make it 8. So now we have 8. So we have octyl. So octyl, because there's a double bond, becomes octene. I want to give it the lowest number possible. So I have 1, 2, 3, 4, 5, 6, 7, 8. It's perfectly okay to number these carbons on your paper. It's actually quite common to see that. So I have 3-octane. So let's break this name down. Oct tells me 3 carbons. Ene tells me a carbon-carbon double bond. And the 3 tells me the location of the double bond. So let's go ahead and look at some in the opposite direction. Let's look at 1-hexane. Before I draw it, let's break this name down. Hex tells me 3 carbons. Ene tells me there's a double bond. The 1 tells me the location of the double bond. Okay, so before you get too deep, after you draw your carbon chain, go back and count it. I've been doing this a long time and I still mess up drawing, so make sure you have the right number. 1, 2, 3, 4, 5, 6. Okay, have to put a double bond that starts on the first carbon. Okay, so there's my answer. What if I did this? 1, 2, 3, 4, 5, 6. Would that be a correct answer as well? Yes, that's the exact same thing as this. Imagine taking this molecule and flipping it over. Okay, if you can flip the molecule around and make it the same, they are identical molecules. So either one of these are perfectly acceptable answers here. It really doesn't matter. So let's try one more. Let's try 2. I already did that one. Let's just try propane. And no, that's not a mistake. That is the proper name. I didn't put a number there, so we'll see why. Go ahead and try that. Okay, so hopefully the prop tells you there are 3 carbons, and the Ene tells you a double bond, but it didn't tell you where. Is that a problem? No, here it's really not, because no matter where you stick it, okay, it's still the same thing. Okay, both of those molecules are identical. So if there's only one option on where the double bond can be, there's no need to necessarily number it there. So now let's go ahead and move on and look at carbon compounds that contain triple bonds. So we call these alkynes. Okay, so they have triple bonds. So alkynes are compounds that contain only carbons and hydrogens, but they contain a carbon-carbon triple bond. So in this name, we'll underline the Yne. Okay? So the good news is this is the exact same process as naming alkenes. It's just you have a different letter here. You have Y instead of E. So let's look at one. So that's the way an alkyne looks. Okay? So it's a little bit trickier to count the carbons here. I'll put the dots here for you. There are 1 carbon, 2, 3, 4, 5. There has to be a carbon at the end of that triple bond. 6. And for reasons you'll learn later, it is kind of standard to draw that straight out of the triple bond. If you don't, it's not the end of the world now, but just be aware when I draw it, you'll see it like this, with the bond coming straight from the triple bond, so know there is a carbon there. So there are 1, 2, 3, 4, 5, 6 carbons. So hex, or hexyl, but hexyl will change to Yne, so HEX, Yne. So I want to number this molecule 1, 2, 3, 4, 5, 6.